Now we are going to start oncogenes. Before oncogenes, I have two main ways for the cancer treatment. Two ways for the cancer treatment were the increase in proliferation, tends increase in proliferation, or decrease in suppression. And oncogenes are totally related with this component. The oncogenes increase the proliferation of cells, and if these genes get a function, mutation convert the proto-oncogenes to the oncogenes, and these increase the cancer risk. And it requires a damage only to one allele of proto-oncogene. Actually, every gene having two alleles. Okay? If you need mutation or oncogenic effect of any of them, then if one gene is effective, you will get effect. But in tumor suppressor gene, both alleles should be affected by the mutation, then you will get effect of tumor suppressor gene. Okay? For the oncogenes, it is a property that one allele of proto-oncogene should be dominant to get the oncogenic effect. We having these genes in our list, and already you guys know, oncogene having some factors, okay? How can we cause the cancers? By the growth receptors, increasing the growth receptors, increasing the growth factors, increasing the signal transducers, nuclear regulators, and cell cycle regulators. These all are the factors that genes are using to make some cell cancers. First, the growth receptors, growth factors, signal transducers, nuclear regulators, and cell cycle regulators. The thing is that we're having some genes with us that are involving the cancers for the ALK, the anaplastic lymphoma kinase, that goes to lymphoma, EGFR, and HER2. Now, EGFR is epidermal growth factor receptor that's causing the lymphoma, but if you guys know HER2, it's a receptor. Human epidermal growth factor 2, my this is called the breast cancer, is overexpression causer. Breast cancer we having the red gene, the red kina, tyrokinase receptor, tyrokinase high is for receptor. And T4 tyrokinase to redirect kilometers to first it hook, it's giving mnemonic to that thing, okay? And BCR-ABL, the PCR is the plaque point twister region that is going to interact with the ABL, the ABL strand, mutant leukemia via oncogene homolog 1. The BCR and ABL make an interaction, and if you guys know, BCR is on which chromosome? Chromosome number 22. And ABL, chromosome number 9. The interaction of both genes causes CNMN and ALN. Okay? And there's others type like JAK2, Janus kinase 2 that will cause myeloproliferative neoplasm, BRF. BRF is it's a beta-associated fibrosarcoma, and it's called a melanoma. But melanoma also called the one wall rotational protein that's from B1-6. BRFA causing melanomas. Melanoma is causing by B1-6, and c-KIT, cytokine receptor, is also called in tumors. MYC and actually MYC proper gene having two varieties, C and N. The C is going to form Burkitt lymphoma, and N is going to form neuroblastoma. If you guys know, the MYC having Pluto chromosome number 8, and it makes an interaction with the chromosome number 14 of heavy chain due to veterinary increasing hemoglobin heavy chains, and if we can't Burkitt lymphoma, okay? And the RAS, GTPase, hence the MAP kinase, can due to which Most commonly we are getting the colorectal cancer, colon cancer, and BCR2, follicular and diffuse B-cell lymphoma is a deal. Okay? This all are oncogene that so important. You have to memorize these all the genes is so important. For exam point of view, the tumor suppressor gene. The tumor suppressor genes are genes that is present at checkpoints and remove all the abnormal cells. But what happening here, instead of mutation, they lost their function, therefore it is called inactive mutation. Already I told you the cancer cells having the two pathways. Increase in proliferation and decreases suppression. Decrease in suppression mean the suppression of tumor suppressor genes and tumor suppressor genes lost their function due to the increase in cancer cells. And you guys already know, if you need if you want to lose the function of tumor suppressor gene, then you have to make defect in both alleles of that gene. Okay? The first gene we are going to study is the APC. The APC is a very important gene that is going to making a colorectal cancer, the starting of the cancer. The cancer start the colorectal benign. It is start growing, that is due to APC. Okay, it is due to inactive mutation of APC. Then there's the BRCA1 and BRCA2. If you guys know, the BRCA1 and BRCA2 is still, and both are responsible for the breast cancer and plus ovarian cancer. The main cancer from the BRCA1 and BRCA2 and breast and ovarian cancer is saying, if you guys know, the BRCA is present chromosome number 17, BRCA2 is present chromosome number 13. And then you're having some other important genes here. That is RB1 and P53. If you guys know, it's the very important point between the G1 and cell cycle. In G1 and S1 phase is a checkpoint. In this checkpoint there is a protein like RB1 and also there is one more factor, TP53. That both genes are responsible for the checking, the fans are good, they don't have any mutation, they have no any abnormality, and then send to the process of division. But if this checkpoint is going to lose its function, then it will be create a suppression, a loss of function in resertion. If any cancer, the RB1 is most commonly for the retinoblastoma, osteosarcoma, and TP53 is going to causing multiple malignancy like sarcoma, breast, brain, lung, leukemia, adrenal lymphoma. It also giving lymphoma syndrome that having the mnemonic of cellular, like sarcoma, breast and brain, L for leukemia, lung, and A for adrenal gland. And secondly, how RB1 is going. If you need cyclin kinase dependent, they having cyclin D, that cyclin D attached with cyclin kinase dependent enzymes, so they become inactive. If you remove the cyclin from there, then cyclin will attack on RB1 and become inactive to it by doing the phosphorylation. These are more genes here like TSS1, VT1. The VT1 is for the originated to admittance keep infected. One thing I want to tell you, the RB1 is present on chromosome number 13 and TP53 on 17, and these both are going to block G1 and S phase checkpoint. Okay? So tumor cells, the tumor suppressor genes are responsible to decrease or do the suppression of abnormal cells to stop the growth of cancers. And proto-oncogene, the proto-oncogenes are responsible for the growth of cancer.